Okay. Welcome back to LiveWork, where today we're gonna be doing some differential equations. Yeah, this is one of the craziest. Well, actually, it's not the craziest, but yeah, this thing is something interesting that I have been studying within within 1 month, I believe. I don't think so, but yeah, today we are gonna be solving these second order differential equations. But yeah, probably some of them did there like yeah there would be, I believe there are some that is a higher order equation. Let's just actually check here. um but yeah, overall it is totally fine for me, I guess. Yep, I just speedrun that. um yeah, all of them is actually a all of them is a second order differential equation problem, so yeah, you don't really need to worry about anything. But yeah, by the way, this thing is from 1803, exam 2. So, and yeah, by the way, this is from MIT OCW. So yeah, you could just study it by yourself. But let's actually go ahead and just try to figure this out first. Okay. For what value of k is the system represented by x double dot plus x dot plus kx is equals to 0? Critically damped. Okay. So basically, for basically for a for a linear equation, um for a linear differential equation, especially for second order differential equations, um you got three different types. The first one is underdamped, and then you got critically damped, and then you got over overdamped. So yeah, basically how would you actually find this out? um the best way is to actually to look at um what are the solutions are. Oh, like, yes. So like, yeah, for example, if it is overdamped, the solutions are all real numbers. For a critically damped, there's only one particular solution. And then and then for underdamped, the solution is a complex number. So yeah, let's actually go ahead and just figure this out. Let me just actually set up my pen first here. Okay, there we go. So yeah, we can actually figure out if it is critically damped is that there is only one solution. And well, yeah, actually I could actually just write this as this guy first here. D squared plus D plus K. So yeah, D here is actually derivative. This is not about discriminants. Wait, is that called discriminants? I believe so. Oh wait, yep, there we go. X, put it at the front there, equals to 0. And yeah, luckily in here we got this equal to 0, which basically makes this system easier for you to actually to compute. So yeah, let's figure out if it is critically damped. It is just by finding out the discriminant. So yeah, basically the discriminant is um, it is b squared minus 4ac. So yeah, basically in here the b here is 1 squared. Subtract this by 4ac, that's 4 times 1 times k, that's 4k. And we want this to equal to 0 because this thing here is critically damped. So therefore we can figure out that k here is equal to a quarter, which is the one that we need to solve. Pretty quick. Okay, for k greater than that value, is the system overdamped or underdamped? Well, actually, let's go ahead and just look at the top one there. Um, so basically, if it is, oh, okay, so like yeah, if let's say for some, actually we can actually just reverse engineer the entire thing, but yeah, let's say for k greater than that value, that means that k would be something like this guy here. K would be greater than that guy there. For k is greater than 1 there. Therefore, we figured out that 1 minus 4k would actually be what to 0. We put that guy there. That means it goes something like this. And this guy here literally means that the discriminant is negative. Therefore, this thing is underdamped. Underdamped. You could go ahead and just check it by yourself, just by plugging in 1, and you'll find out that it's -3, which is underdamped. There you go. Good. Okay. Um, suppose a solution of x dot dot plus kx dot plus kx equals to 0 vanishes at t equals to 1, and then again for t equals to 2, but not in between. What is k? Huh. When you say it vanishes, for me personally, vanishing is basically stating that x would equal to 0. That's how would I actually state that, and that would literally mean that this guy here is a underdamped situation because it crosses 0 at 2 different points. Uh, but then uh, but then you need to figure out what is k. Basically, there is this thing called a pseudo period. So yeah, first things first. Let's go and compute the pseudo period. That would be 2 minus 1 times 2. That means it's 2. That's the pseudo period. And then after that, you want to figure out what is the literal period. That would be pi. Why? It is 2 pi divided by 2. And so, what? And so you could actually use this equation, which I don't know how you actually use this. You take the square root of k over m. In this case, m here is 1. M is from the double derivatives coefficient. So yeah, you have k there. Subtract this by b squared. B squared in b over m squared. So like yeah, the m here is 1, but then the b is also 1, so that means it's k minus 1 there. Therefore, k would be pi squared plus 1. That's k. Okay, and I believe that's the answer. Let's actually go ahead and just check, just in case. Yep. Oh wait, no, actually, no. I think, yep, I messed up somewhere. Hmm. Hmm. Oh, why did I mess up? Is it because I actually used a different one? Let's actually look at the study guide. Because by the way, I am not doing this exam because I'm just self-studying. But yeah, I'm here just checking. I'm just checking my entire methods. Let's see. Okay, there it is. Is it b over 2m? Oh yeah, it is b over 2m. So therefore, so it's b over 2m, so that would be quarter. Therefore, this would be pi squared plus quarter, and that's your k. Okay, so I've studied that it's actually b over 2m instead of b over m. I'm so sorry, but yeah. Um, and then I should see how you actually found this pseudo period. No, sorry, how you find this. See the period. It's just by doing some yeah, some stuff that I don't really understand about because I'm not really a mathematician anymore. So like yeah, do I even care? Okay. Um, find a solution of x dot dot plus x equals to 5t e to the power of 2t. Okay, this thing here is actually a pretty simple thing to solve. Well, actually, it's not that simple, but yeah, you could say it is pretty simple. So like yeah, you got d squared plus 1 x equals to 5t e to the power of 2t. Okay. Okay. So the way that I would actually do this is to figure out corresponding what is the corresponding function if it is equal to 0. In this case I figured it out. It is actually d squared is negative 1, which is d equals to I. Therefore I figured out that yeah, basically the function would be a cosine of t plus sine of t c2, sorry, c1 sine t. And you might be actually asking me, how do you actually get these things here? Well, basically, uh, so yeah, you first actually try to find where would d squared plus 1 equals to 0. In this case, it's d squared is negative 1 or d equals to I. And d equals to I, it is a underdamped situation. So therefore, you have a formula just to find out what it is. In this case, it's and cosine and sine. But yeah, for but yeah, for completeness, it is actually e to the power of 0, which in this case is 1. And where do you actually get 0? It's basically 0 plus I equals to I. So yeah, for example, if it is 1 plus I, it would be e to the power of 1. Okay, c1 is a arbitrary constant. Multiply this by cosine of t. Where do you get the t there? It is basically 1 times t, and where do you get the 1? It is basically, you take the imaginary part, but you forget the I. That's how I actually say it. And same thing for the sine t. So this is called the corresponding x. This thing should be x. xc would equal to this way. Okay. But this is only xc. We also need to figure out. Oh wait. Oh wait, actually. 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 Oh my gosh. Well, actually, the first thing that I was actually thinking, like, wait a minute. You only asked me to find a solution. Then why do I actually even care to write it in this way? Like, yeah, it is not really important because you only want to try to find a solution. You only want a solution. So therefore, you could actually just figure out the particular solution straight away. The way that you actually do this is just by actually changing this guy into, like, yeah, you want to have like the particular solution to be something that would actually go and help this guy here. First thing that I would obviously think about is obviously a times t of e to the power of 2t, and also b of e to the power of 2t. So yeah, basically if you have like a power, you just basically keep it on, and then yeah, the t would actually just degrade. So yeah, that's basically how I would actually say it, but obviously it's not really that specific. And so let's actually try to figure out if you take the first derivative there. The first derivative would be, let's actually compute this guy straight away there. I am writing this on my iPad because like yeah, it is much more easier for me to compute there. So okay, a ate to the power of 2t, when you take the derivative, that would be a product rule, so it's ae to the power of 2t plus 2ate to the power of 2t. Add this by be to the power of 2t multiplied by b. And so what I'll get is actually this 2at e to the power of 2t plus a plus 2b e to the power of 2t. Okay, that's pretty quick. And now you want to find out the second derivative. So you go ahead and just do this there. This would equal to, let's actually go ahead and just compute this thing here. Same thing on my iPad, just to make sure that this thing is correct and also fast. So yeah, t e to the power 2t, same thing, that would be the product rule. That's 2a e to the power 2t. Add this up by 2a of, no, 4a of a t e to the power 2t. Add this up by 2a plus 4b e to the power of 2t. And so what you'll get in total, that would be 4a t e to the power of 2t. Add this up by that's 2a, okay, so it's 4a plus 4b e to the power of 2t. Okay. That's so tiring, but yeah. Let's go ahead and just check that again, just in case I made a mistake. I don't think I made any mistake there. You take that, yeah, that's correct. Yep, it's all correct. And so, when you actually just try to compute this starting, you want to go ahead and just add this guy up with this guy, because that is what it is wanted. You want to take the second derivative, add it up with the first derivative, and hope you could get this guy here. So, I will actually do this on my iPad as well. There will be 4a t e to the power of 2t plus 4a plus 4b e to the power of 2t. Add this up with 5a with a t e to the power of 2t plus b e to the power of 2t. Summing those two up, you would get 5a t e to the power of 2t plus 4a plus 5b e to the power of 2t. Therefore, you can actually figure out that a is 1. Well, actually, I would actually just go ahead and just do this up. 5t e to the power of 2t is actually equal to 5a t e to the power of 2t plus 4a plus 5b e to the power of 2t. Okay, so yeah, first thing first, this guy here should equal to 0, this guy here should equal to 5. Therefore, I figured out a must equal to 1. Therefore, 4 plus 5b equals to 0. That means b would be negative 4 over 5. And so you would actually get, um, let's try if I can actually write this down. T e to the power of 2t minus 4b e to the power of 2t over 5. So we can actually go ahead and just check that again. Oh, whoops, my bad. So yeah, you take the derivative there, plus t 2t e to the power of 2t minus 4 over 5 e to the power of 2t multiplied that by 2. That's negative 3 over 5 e to the power of 2t plus 2t e to the power of 2t. And then after that you take the second derivative again, minus 6 over 5 e to the power of 2t. Add this up by 2 e to the power of 2t plus 4t e to the power of 2t. Therefore you would get 4 over 5 e to the power of 2t plus 4t e to the power of 2t. Okay, and yeah, it actually follows what we want. Good. So this is actually our solution. Good. And so, suppose that yt is a solution of the same equation, such that y0 is 1 and y dot 0 is 2. This is probably not the solution you found in A. Use yt and other functions to write down xt such that x0 is 3 and x dot 0 is 5. Okay. Okay. So we want to find another function that would also satisfy this thing. Okay, first things first, we last time have already calculated what the complementary solution is. If you have forgotten it already, it's cosine t plus sine of t. You take c2 and c1. There. Okay. And so you want to sum this up with your particular solution, and that should be one of the solution. So that would be c1 cosine t plus c2 sine of t sint plus t e to the power of 2t. Subtract this by 4 e to the power of 2t over 5. Okay. So what happens when this guy is actually evaluated at 0? So you go ahead and just plug in t equals to 0. You would basically get, okay, first thing, sine of t, that would actually cancel that entire thing out. That guy there would be c1 times cosine 0, that's 1. And then this guy t for 2t, that's 0. And then minus 4 over 5. E squared t, that would be 1. So that's negative 4 over 5. Minus 4 over 5 would equal to 1. Okay, so we figured what c1 is pretty quickly actually. That would be 9 over 5. And so, what about when you take the derivative? Let me actually just compute this in my tablet first. That would be 9 over 5. That's negative 9 over 5 sine t plus c2 cosine t plus e to the power of 2t plus 2t e to the power of 2t minus 4 over 5, 8 over 5 e squared t. Okay. So when you actually compute this guy here, y dot here would equal to minus 9 over 5, the one that we have already calculated already, sine t plus c2 cosine t um, plus t e to, no yeah, plus 2t e to the power 2t um, minus 3 over 5 e to the power 2t. Okay, that's that. So when you actually just compute this entire crazy thing, let's actually go ahead and just figure this out. What happens when you actually evaluate this towards 0? Sine of t, that's 0 plus c2. So yeah, that will be c2. Subtract this by 3 over 5 would equal to 2. Then, therefore, I know what c2 is. That would equal to 13 over 5. Good. Therefore, we figured out what the function actually is. Y is 9 over 5 cosine t plus c2, nope, plus 13 over 5 sine t plus te squared t minus 4 e squared t over 5. And now we have this other problem here. When x0, use yt and other functions to write down the solution xt such that x0 is 3 and x dot 0 equals to 5. So it is actually only a bit different, but it's generally the same. I could actually confidently say that, yeah, this guy would be yt. Okay. And then what happens to c1 here? Logically, c1 would actually be 19 over 5 because like yeah you just basically replace that with 3, therefore you got 19 over 5. Or you could basically state that it's actually added it up by 2 cosine t and then after that you have this x dot 0 is 5. So when you basically plug that in, that's 5 inside there, that would be 28 over 5. Or you can basically state add it up by 5 sine t. And that's that. Quick, right? Yeah, it's so quick that you could actually just think it outside your head. For me personally, I know, I'm so sorry that I just touched on that. But yeah, that is one of the solution. Good. Let's actually go to the next problem. And I don't have any water near me because I really want to drink. Okay, you know what? That's fine. Let's go to the third problem. And yeah, by the way, we have about not about, we have exactly 5 problems. So yeah. Oh wait, never mind. We have the third degree problem. Okay. Ah, consider the equation x dot dot plus bx dot plus kx equals to cosine omega t. We will vary the spring constant but keep b fixed. For what value of k is the amplitude of the sinusoidal solution of x dot dot plus kx equals to cosine omega t, the maximum? Your answer will be a function of omega and may depend upon b as well. you want to find out what the omega is. How would you actually do that? My intuition states that it might work. My intuition says that it might work. Yeah, it might work. You know what? Let's actually do that. Okay. Because this thing is only cosine omega t, I could actually basically write this as e of I omega t. But you only take the real value, and then you just divide this entire thing by um, you basically plug in I omega into d squared plus bd plus k, and that would basically be wait, this is actually the solution, right? Isn't that actually one of the solutions? Yeah, yeah, that's one of the solutions. So therefore, in order for me to figure out what the maximum is, like yeah, when you want to try to figure out what the maximum is, I guess you shouldn't. But yeah, you could actually just figure it out by yourself. Okay, well, um, I would say that I don't know how to solve this. No, don't do that. Um, I like yeah, I'm still actually thinking about this a lot. I'm thinking about this a lot. Ouch. Okay. You know what? Let's actually continue. I omega with the d squared there, that would be a negative omega squared plus ib omega ib omega plus k. Okay, we figured this out. Therefore, I want to figure out the real value of this entire thing. I know, cause I know. Okay. Um. Wow, it's getting a bit tired for me. So basically, you can actually just rationalize the bottom one there. Well, yeah, you can actually say that it's actually rationalizing. You know. You know what? I should go ahead and just write this guy down. K minus omega squared. You square this again. Add this up by b omega squared. Let's see. I'm just solving this type equation crazily. This would actually be painful to do. Anyways, let's actually keep on doing that. Cosine omega t. Omega t. And then this one here is actually k minus omega squared. No, that's a plus b sine omega t. Okay. Therefore, if we want to figure out the amplitude, you would only need to solve this one single problem, because the rest in here is actually imaginary. Therefore, the only thing that we are actually concerned about is square root of the entire thing there plus that entire thing there. K minus omega squared plus b squared. And we basically have figured this out to be 1 over square root of the starting k minus omega squared plus b squared omega squared. And we want to maximize this guy. Therefore, we need to minimize the bottom side. Okay. Omega will be something that... So it is a function of omega. It is also a function of something else. No, I believe it's only omega. You know what? So if you want to figure out the max, you want to figure out the critical points, right? Because that's basically how you would figure out this entire thing. So in order to maximize this, we want to minimize the bottom side there. So we want to make sure that k minus omega squared plus b squared omega squared would be minimum. We want to actually go and actually take the derivative over k, as that would actually give us what k would make into 0. Okay, let's try to do that. Half of k minus omega squared plus b squared omega squared negative half multiply this by 2k minus omega squared, multiply that by 1 equal to 0. Okay, I figured something out. K minus omega squared over square root of k minus omega squared plus b squared omega squared is 0. So I think k is omega squared. Well, yeah, actually k is omega squared. Yeah, actually k is omega squared. So you would actually figure out that k is omega squared, but obviously you wouldn't believe me because I didn't actually do the second derivative test. That's why I'm gonna be doing that. Yeah. Doing that, yeah. So I would get k minus omega squared plus b squared omega squared. Add this up with the no, subtract that by k minus omega squared of that entire thing there that I've already written down. K minus omega squared divided by square root of k minus omega squared plus b squared omega squared. Divide the entire thing by k minus omega squared plus b squared omega squared. There you go. Oh wow. And yeah, I'm just doing this in my tablet as well. This guy here is always positive, we know about this. This guy here would be a positive. This would be a 0. So yeah, it's basically positive, which means it's a minimum. So yeah, we have basically proven this guy, but yeah, obviously I didn't actually write the entire thing down. But yeah, when you actually take the derivative and then you want to figure out what value of k would it actually equal to 0. In this case, it's k is omega squared. Very good. And okay, part B. Find the general solution of that. You might think that this is hard. This is a third order, but yeah, it's actually very simple. You do this first. This must equal to 0. Okay? Um, so, oh, what just happened? Okay, so first thing is that we want to factor this out. D minus 1 and D plus 1. Okay, D plus 1 there. This would equal to 0. And yeah, basically we want this to be a general solution, but yeah, when it actually equals to 0, particular solution is 0. So yeah, we only need to find the complementary solution, which in this case we have already figured it out. It's E, the first one there, it's 0. So it's E to the power of 0. That would be 1. Or you could basically state that as C1. And then you add it up by C2 of E to the power of this guy here is D would equal to 1. That means that it's E to the power of T. Add this up with C3, E to the power of negative T. This would equal to the X. And that's the general solution. It's simple, right? I know, it's simple. And then you can actually go ahead and just check it out. Because like, yeah, in fact that, yeah, this first constant here won't actually contribute anything at all. So it's actually C2 e to the power 2t, and then you just do the crazy other thing, and then you would actually figure it out that this guy would actually be, that would be a 0. If you have actually done lots of deriving. Okay. 4. A certain system has input signal y, and system response x related by the differential equation x dot dot plus x dot plus 6x equals to 6y. It is subjected to a sinusoidal input signal. If it's sinusoidal, that means that, yeah, it is like a curve, such things. Therefore, I hate this. Therefore, I hate this. Well, okay. Y here would be a sine omega t. No, let's actually put that into cosine. No, actually, instead, you could actually write this guy as cosine omega t. Subtract this by some certain value. Multiply this by a certain constant, and that will make it a sinusoidal input signal. Signal. But actually, somehow, you could actually just turn it out into something like this. Cosine omega t. Wait, what? I don't know. So yeah, let's actually just use cosine omega t because, like, yeah, that's the most easiest one to use. So it's 6 cosine omega t. So we want to compute the complex gain. That's actually simple. It's 1 over. Well, yeah, basically the previous one, you could also use the same logic to figure that out. So yeah. So yeah, this guy here is e to the power of it. So yeah, no, e to the power I omega t. So so it's I omega t. When you do the thing, it's negative omega squared plus I omega plus 6. And that's the complex gain. 1 over 6 omega squared plus I omega. And you can basically write this guy again if you want to make it into a much more nicer view. It would be 6 minus omega squared plus omega squared. No, plus what? No. No. It's minus I omega divided by 6 minus omega squared plus omega squared, which is something that I won't really actually compute because I know that would be a 36 minus 11 omega squared plus omega cubed. But yeah, I am too lazy to solve this, and then somehow that there's a 6 at the front. I always forgot about this. But yeah, basically if you have something like that, you should just like add in like the 6 there. Because like yeah, logically it also needs the 6, but yeah, I always forget about that. Okay. And that's the complex gain. And then compute the gain at omega is 2. Computing that entire thing inside my head would actually give you out a 6 over 2 plus 2 I. That's 3 over 1 plus I. That's actually equal to 3 minus 3I over 2. Wait, is it 2? No. Oh, yeah, wait, no, yeah, it's over 2. And then you obviously take the real value, so it would be 3 over 2. Somehow it's wrong. Oh yeah, actually. The gain here is not actually taking the real value or not. It is actually taking the absolute value. So yeah, it's 3 over square root 2. Okay. So I figured that out. Okay. C. Compute the phase lag at omega is 2. So you want to basically take the phi at omega is 2 for the complex gain. So yeah, you just figured that out. So it's 1 minus I. That's basically this one. This guy here is actually minus pi over 4. And that should be the answer. Nope, it's not. Oh yeah, you basically need to take the negative sign out. It's the negative arg. Okay. Okay, well, at least I'm actually studying a bit. But yeah, most of this is that I actually calculated it myself. But yeah, obviously I forget about some stuff because I didn't actually study for this. Okay, but yeah, that's how I actually go and just approach the problem. Suppose that half t sine 2t is a solution to a certain equation mx dot dot plus bx dot plus kx equals to 4 cosine 2t. Write down the solution to mx dot dot plus kx equals to 4 cosine 2t minus 1. Okay. I think this is all about complex gain. The complex gain would actually be something. The brave paradise. Wow. Wow. Look what we have got. here. According to my intuition, it's half t cosine 2t minus 1. I don't know why, but logically it is half cosine 2t minus 1. Nope, it's not. Okay. How would you actually solve this star equation? This is all about time invariance. It's something that I don't really actually remember. Let's actually open this up. Um, 1803. Um, at the exams, I believe, and then there is like the practice exam. There's the study guide. Oh my gosh, I'm starting to yawn. Okay, there it is. Time invariance. If p dx equals to qt, then y equals to xt minus a. Solve p dy equals to qt minus a. This is how to convert any sinusoidal stuff. And qt to a cosine. Then y equals to xt minus a. Okay. Let's try to use this logic. X here is 2t. Y would be 2t minus 1, which is t minus half, which is 2 times t minus half. Therefore, using the same logic, it's half t minus half sine. Yes, sine 2t minus 1. Okay. What about this one? My intuition, basically just multiply the solution by 2. Yep. It is actually just multiply that by 2. Well, that's easy. And then determine b, mb and k. Okay. This one you need to compute the entire thing. Where's my pen? Where did I put it? Where did I put my pen? Okay, figured it out. So okay, mx dot dot plus bx plus kx is 4 cosine 2t. We want to figure out the solution that satisfies this. X here is half t sine 2t. Therefore x dot here would be half sine 2t plus half t cosine 2t, multiply that by that guy, which would actually be only that. And so x dot dot would equal to cosine 2t plus cosine 2t minus t sine 2t multiplied by 2. Therefore you would get 2 cosine 2t minus 2t sine 2t. Okay. Therefore, when you figure the entire thing out, it would be 2m plus b over, no, I only care about the cosines. Wait, actually, you know what? Let's actually just write them all out. Minus 2mt sine 2t um, plus b over 2 sine 2t plus b times t cosine of 2t plus k over 2 t sine 2t. Okay. And so when you sum the entire thing up, it's gonna be crazy. Cosine 2t there. It will be 2m plus bt of cosine of 2t plus, for the sine 2t we got minus 2mt plus b over 2 plus k over 2t sine 2t. And so we want the solution to only contain cosines. Wait, do we need to actually do like the squares? The form the solution. Oh. Huh. Wait, actually, that might actually be the crazy method. The crazy method. M is 2. Yep, figured that out. B is 0. Therefore K would be 8. Yep. So basically, for me personally, I did actually just figure out what's half t sine 2t, just plug it into the formula, and then you would actually get yourself to be m is 2, 0, and 8. But yes, according to the practice exam solution, no, sorry, for the exam solution, the solution is actually a form of 2i, which is something logical, but then it is only, wait, no, sorry. But then using that logic, you could actually figure out that, yeah, because the 2t, you would actually figure out that b is 0, and then that guy is 4, and then by the exponential response formula, mz, wait, what? You use the response formula? Wait, what? I guess that would work, but yeah, for me, just by computing the derivatives would be faster. And yeah, that's actually the entire thing. Oh wow. So yeah, I know this LiveWork, I didn't actually did lots of those crazy tricks that I have in my mind, but I hope that this would actually help to just actually to know what is actually on my mind. But yeah, thank you very much for you guys who have already watched, and yeah, I will see you guys later on. So yeah, goodbye.